In this video, we shall look at problems involving surds. Let's start with this problem. Well, it seems like there is quite a lot of information given. Now, the first thing that we need to do is to understand the problem by looking at the information given and what is required. Let's run through the problem line by line. Here it says that a ladder with a length of square root of 54 meters is leaned against the wall. Maybe we could draw a diagram to help us understand this better. This means that we have a ladder with a length of square root of 54 meters leaning against the wall. Next, it says if the base of the ladder is 2 meters from the wall. Do you know what it means? Yes, this means that the distance of the base from the wall is 2 meters. Notice that from the given information, we can form a right-angled triangle. Then it says, find how high up the wall the ladder will reach in the form t times square root of 2 meters, where t is an integer. This means that we are required to find the vertical height of the ladder above the ground, which is in the form t times square root of 2. Great! Sometimes diagrams really help us in visualizing and understanding the problem better. Now that we have understood the problem, we need to devise a plan. Look at the right-angled triangle. Can you think of the relationship between the sides of the triangle? Yes, you're right. We can apply Pythagoras' theorem to form this equation. This will bring us to the next step, which is to carry out the plan. First, let's rearrange the terms in the equation so that the unknown is on the left-hand side of the equation. Now, do you know what to do? That's right. We can simplify the equation to get this. Remember, we want to find how high up the wall the ladder will reach in the form t times square root of 2. So we should take square root on both sides of the equation to get this, which is this in its simplest form. Now, since the value of this must be greater than 0, we can only accept the positive answer. Therefore, the ladder is 5 times square root of 2 meters up the wall. Next, let's look at another problem involving surds. Again, the first thing that we need to do is to understand the problem by looking at the information given and what is required. Again, we can draw a diagram to help us. Here, it says that area of the rectangle is square root of 150 square centimeters. This means that we are talking about a rectangle with this area. Next, it says if its length is 4 minus square root of 6 centimeters, do you know what it implies? Yes, it tells us that this is the length of the rectangle. Notice that so far we are given information about the area and length of this rectangle. Then it says find its breadth in the form h plus k times square root of 6 centimeters, where h and k are integers. So we need to find breadth of the rectangle, which is in the form h plus k times square root of 6. Now that we have understood the problem, we need to devise a plan. Let's look at the diagram again. You have a rectangle, and you know the area and its length, and you need to find its breadth. Can you think of the relationship between the area and the dimensions of a rectangle? Yes, you're right. The area of the rectangle is equal to the length times breadth. This will bring us to the next step, which is to carry out the plan. Now, breadth is actually equal to the area divided by its length. Filling in the information will give us this. Now, do you know what to do? That's right. We can simplify this expression from this to this. Using the equality property, we can equate the rational terms to get the value of h, and compare the coefficients of terms with the same surd to get the value of k. So, the breadth is 2 plus 3 times square root of 6 centimeters. Finally, let's look at one last problem. Like in the previous examples, the first thing that we need to do is to understand the problem by finding out the information given and what is required. Like always, let's go one line at a time. Here, it says that the base area of a cuboid is 6 plus 2 times square root of 3 square centimeters. Now, the word cuboid tells us that we are dealing with a three-dimensional object like this, and that its base area is given by 6 plus 2 times square root of 3 square centimeters. In the next sentence, it says that if its height is 5 minus square root of 3 centimeters. Do you know what this height is referring to? Yes, it refers to the height of the cuboid. Again, notice that we are given information about the base area and height of this cuboid. Then it says, find its volume in the form P plus Q times square root of 3 cubic centimeters, where P and Q are integers. Can you see that we are required to find the volume of the cuboid, which is in the form P plus Q times square root of 3? Now that we have understood the problem, we need to devise a plan. Like in the previous example, let's think of the relationship between the given information and what we are required to find, which is the volume of the cuboid. What is it? Well, the volume of a cuboid is actually given by its base area times height. Did you get it correct? Next, it's time to carry out the plan to find the volume of the cuboid. Replacing by what we know will give us this. Do you know what to do now? That's right. We can simplify this expression to this. By the equality property, we can equate the rational terms to obtain the value of P and equate the terms with the same surd to obtain the value of Q by comparing their coefficients. So the volume of this cuboid is 24 plus 4 times square root of 3 cubic centimeters.